It's kind of hard to see on here, but all the different colored main you can see is the different pressure zones. So this is our pretty close to our system.
Is this your
the boundary?
Your whole plant?
Yeah. Oh, it's okay.
What's wrong with that guy?
Let's just zoom out a little bit. So
all these little, where all these little sections change colors, each one of those are a little zone that's that we have as-built for. So when he zooms in, you'll be able to sell it. So like that was like a new construction area, you know, so each water line in that area we have, you know, as-built for. And this program allows us just to zoom in and pull up that water system right for that street, what year it was built, what kind of pipe is there.
So that's basically Lake Oswego's boundary here.
That's our whole boundary.
So stuff that's under construction right now?
No, that was constructed in the past. Whenever.
Oh, okay.
This is all just past stuff. When they do new construction, it's about a year before we get these as-bills back from the contractor and it's signed off. And so like I say, this whole, like Mark was saying, this is our whole water boundary. And there's a little sections that are outside of our boundary. I got another map I can show you that.
Like they're going over to River Grove after this.
Oh, okay. Yeah. So all these numbers those are actually as-built numbers. See, there you go. You can see each one of these sections has its own as-built numbers and actually as-built. So we can go.
As-built's just the name of the program, is it?
No, that's like the construction plans. It's a computer copy of that.
So blueprints.
Of the blueprints.
Oh,
okay. We used to get them actually on microfiche, if anybody knows what.
Yes, microfiche.
Yeah, you can see we still have one in the back there.
A few of us are old enough to remember.
Yes, a few of us.
Test question number 5. So basically, here's the construction plan profile, and so then here's the roads that was put on Quarry to Harvey. Let me zoom in here just a little bit. So it shows in more detail of that road. See, so then here's the water line. It says 8-inch ductile iron, push-on joint type. So here's the water line, and then these are the water services.
Okay.
So it kind of gives us an idea where the services are.
Is that the trees, 24 fir?
Yep. So they kind of did some reference points. This map is pretty old. Let's see, let me zoom back out here.
Put the trees on there though, that's good.
Yeah.
Help with the infiltration.
Oh, yeah, I didn't know.
Yeah, tree roots will help with infiltration.
Yeah.
So yeah, like I say, so that's just for that area there. Now, this program that we have here is pretty neat that we can switch. Let me change here. We can just go to where it shows just the water lines. We kind of get past the as-built part. Let's see, come on. So theirs gives a little better idea of the whole water system. It's all in the dark blue. And then here's the lighter blue. This is Lake Grove water system. And then we have Skyland Water District, Glenmore Water District. All those kind of just come in and out of our area.
Where are we on this map?
We are right here.
Okay.
So, and then River Grove actually takes over some of this area down here. It's kind of a bad color. It's kind of a purple. So is that where you said they're going to go later?
Yeah, River Grove.
Yes, we're heading to River Grove.
Okay.
Part 2.
Yeah. So their area is this area here, which is all kind of out that way towards the river. But it's pretty neat system. And so here, it's kind of the same thing. We can just zoom in, and we'll actually get to where you can see all the water lines. See, now they populate. The blue is the water line, and then these are valves, and then these are fire hydrants. So we can tell where all the valves are, end of runs. These are connection points.
What kind of valves are they?
We use all
Rising Sun.
rising stem gate valves.
Right instant.
Rising stem.
Rising stem. And what, is there a reason for that?
I guess our.
You prefer that
I
kind?
think ground ones would be. Ground just be a resiliency.
Resilient cedar, the other ones that we use, yeah.
Those brass
Um,
or.
Resilient cedar rubber, and yeah, they're rubber, and it's all epoxy coated inside the valves. We do have a few butterfly valves, which are all brass
We've got
style.
one in our storeroom you can look at too.
Is this a specific reason why you like those two kinds?
The resilient seated ones, the rubber ones, they tend to not gather, you know, what do you want to call it?
Debris rust.
Debris,
yeah.
rust, so then they work a lot easier. And they're all part of the AWWA standards. You know, we have to go by all that, but,
The butterflies, typically after like 10-inch, we try to use butterfly valves. They're just
easier to operate
yeah, easier
with
to operate.
pressures because of the pressure on the valve. You know, 8 and 10-inch, you know, since the seat's going up and down, you don't have that much issue with the pressure. You know, it's pretty easy to move them. But butterfly valves, when you get over 10, 12-inch, when that water pressure is high on one side and there's no water on the other, it's pretty hard to make that turn. And so with the butterfly valve, when it slightly turns, it releases that pressure instead of trying to force it up again, you know. So it does work pretty good. And we have one other little, so this is, we actually use this program a lot. We actually just integrated computer tablets for the crews, and so they can access this information directly from the field.
Do you guys use corporation stops at all?
Yeah.
Yeah.
Mm-hmm. One of those is
And Mark will go over all that stuff.
Brass.
So
Yeah.
I'll show you some in the storeroom.
And this map here basically is the same as what our paper atlas. That's what this one here is generated from. We still do carry paper maps, books. So each one of these sections is basically a map page. We actually cut it into 4s past that, but this is a quarter section, just like a Thomas guide. So we can actually just go off of that.
How big are these grid squares? I mean, are they covering like
There's 1 square mile.
1 square mile? Okay.
Yeah, and so then we actually cut them into 4s to fit in our map books a little better. But on this one here, it's easy to see the different colors are different pressure zones. So we have basically 20 different pressure zones. We have 10 reservoirs, and we have basically 20 different pressure zones. You have the standard pressure zone, like here. This is the highest point of Lake Oswego, is Nansen Summit. So then basically this first section of Nansen Summit is the pressure from that tank because of the altitude difference. So then here we change to regulated summit pressure, which is the secondary color.
Are all those reservoirs the same size?
No, we range from,
500,000 to 5 million.
yeah,
100,000 to 5 million?
500,000
5
to 5 million.
yeah,
To 1 million?
to
5
5
million.
million.
5 million.
Yeah, actually, there is a 5 million gallon tank right here, and it's right across from another 1 million gallon tank that they tied together.
Those underground?
Yes. Not all of them are underground. We do have some that are half exposed. Some are concrete above ground. And then we have
2 steel.
two steel tanks, vertical cylinder tanks.
Now, does this map, I don't see any contour lines about changing elevations or anything like that, so.
Right, we don't show that on here.
Okay.
But there is quite an elevation difference. The top of Nansen Summit here is just a couple feet shy of 1,000 feet,
Wow.
where lake level is 98 feet.
Oh, wow.
So that's a lot of, drop. So we have a lot of, our big issues are that change in water pressure, that we have a lot of regulating stations and to compensate for that water drop, pressure drop. Actually, pressure increase, sorry.
I was gonna say, do you
Yeah.
ever get a pressure increase that you have to like regulate the system to cut that down? Cut it
Yeah,
down, cut it
we
down?
have, I don't know how many regulators we have.
Quite a few. Here's a list of all of them, so 29.
29 regulating
Close to,
stations.
yeah.
And there's some areas even outside of the regulated areas, down in this little purple area right here. Most of the houses in there have about 120 psi, which is really pushing the limit. But at the time when that was installed, there wasn't any standards for that. You know, regulated now, everything has to be 80 or less. So at that time when we supplied water, that was good. So we still have a lot of home individual pressure regulators that we put in now. You know, when they start having issues, we do install ones on the services instead of just a whole main line.
And is the owner responsible for monitoring that, or you guys?
The
We
owner's
actu-
responsible now for it.
Yeah.
It used to be that we did it, but it just became too much. So, yeah, they're responsible for it now.
What's the
Sometimes
normal PSI the house would receive?
it varies pretty greatly through here, anywhere from 25 to 100.
Okay.
So, like downtown area, they've got pretty low pressure, like 25-ish. And then, you know, average you see 60, 40 to 80,
And that's because of the elevations?
just because of all the drastic elevation changes, yeah.
And since this is pretty flat elevation from here to wherever we can get higher elevation reservoirs, the water for this section here actually comes from way over here off of Boone's Ferry. So I mean, that's a long ways for that water to travel just to give them adequate pressure, because we have a reservoir here that's an above ground, but to even get enough pressure, because this area is so flat, that their water pressure doesn't kick in until this lower half of downtown. So, I mean, we do move water all over to be able to get to, you know, to keep people in the right pressures. Our water, let me back out just a little bit farther. Our water treatment plant is actually in West Lynn. I don't know if you've heard about it. We've been in the news quite a bit lately.
Getting
Had
some
debates on it
publicity.
in class.
Yeah.
Pros
So
and
our
cons.
water comes in, we actually bring our water off of the Clackamas River, and then we treat it there in West Lynn, and then it comes in Highway 43 into town. And here at the park, it actually splits to feed both sides of the lake. So the one main line comes around town and feeds our main reservoir and pump station, which is Beluga. And then the other half comes into town and through various pump stations pumps up to the highest point, which is Cook's Butte. It's one our other higher point. And same with the one that comes on the north side of the lake, goes to Beluga and goes through 4 different reservoirs and pump stations until it gets to the top. Our whole system is gravity fed, even though we have all the pump stations. All that is for is to move it from one elevation to the other, move it up to one tank, then we pump from one tank farther up the hill from there. And but the residents all basically are off of gravity fed pressures. There's a few areas where there's the pumping lines that are on all the time, that there's houses on, but we still have to regulate that for them.
What park was that it splits in?
Beluga Park is one of the main feed stations. That all the water coming from the plant goes to that reservoir. And then on the other side of town, we have a booster pump that then starts at south side, which is the main one on that side. It starts moving it up
That
the
where,
hill from
where
there.
it splits, that was at the park?
Yeah, at Beluga, George Rogers Park.
George Rogers.
Yeah. Any other questions?
Any questions? An overview of where the water goes from the plant?
How many people does it serve? Your system?
We serve 13,000 meter connections is what we have for Lake Oswego. And that's industrial and residential. We have about a little over 5,000 fire hydrants that we maintain. Yeah, yeah. I don't remember how many miles. About 210
Yeah,
miles.
it's
Is that? I
yep.
think that's what about it is. 210 miles of water lines. Our largest water line is 24 right now.
The raw water line's 30.
The raw line's 36. Yeah, we have 2 raw water lines that come in from our river intake plant that go underneath the Willamette River. That they actually pump the water underneath the Willamette River to our treatment plant.
What's your peak output?
We're at right about 16 million gallons a day.
16 million gallons a day?
And that's during the summertime. That's about our peak output.
So here too, I think we're only allowed like 30, something like 30 million.
Capacity.
That the state allows us, 38 million gallons per day.
And that's part of, we are actually, I don't know if you've been going over some of that, the LO Tiger project stuff.
Yep.
We'll be sharing water with Tiger now. And that's where some of those increases will be coming, because we can't supply water, that much water right now.
So you're basically as big as you can be right now.
Right. And we're actually over pumping in the line from the plant to town. So it's getting its wear.
Right.
Tiger, does that expand your realm, what you guys will be responsible for, or how's that gonna work?
Actually then, only just a little bit of, they're gonna have partnership in the plant itself.
Okay.
So they will have some dollar value of the water plant itself and river intake.
Okay.
And then when the line comes through town, they're doing a whole new line all the way through town, so that part of that new main line we'll share those fees.
Okay.
For that. And then at Banky Road, over just before I-5, there's going to be a pump station and a master meter there that they will take over possession there. And
Building a new reservoir by the existing reservoir also.
yeah, right off of Carmen Drive, which is, well, I don't have it on there. If I can get there. Drive, this is where our Waluga Reservoir is that I was talking about earlier. We own this property here next to it, and we're gonna put in another 5 million gallon tank there that will actually, that's where it'll store the water.